Today we're going to work with empirical formula using mass percentages. Molecular formula and empirical formula. Empirical, simplest ratio of atoms. You simplify it down and only have whole numbers. Molecular formula is the actual number of atoms. They're both the same as far as your mass percentage composition is concerned. So for our example, the first thing you need to do when you are given a bunch of mass percentages to find an empirical formula or even a molecular is you assume a sample mass. You can assume any sample mass that you would like. It's just easier to assume 100 grams because if you assume 100 grams, well, your percentages convert directly into grams. So instead of 25.4% of sodium, you have 25.4 grams of sodium. This works because these are mass percentages. The next thing to do, empirical or molecular formulas are a count. Moles are how we count things, so you need to put things in terms of moles. So take those grams, those masses you've just determined, and convert them into moles using your molar mass. The trick with this is when you get these moles, you're not going to use these generally in any answer. You're going to use these to find another answer. In that situation or in any calculation situation, don't cut your sig figs off. Don't round. A good rule of thumb, keep 4 or 5 sig figs when you can. In your final answer, your final step, feel free to round those sig figs off. The next thing you do, you've got to make a ratio. That's all any formula is. It's a ratio of the elements. So you divide by the smallest. And as long as they come out close to a whole number, that's the amount in your empirical formula of each piece. If they don't, we'll talk about that in a bit. Okay? So let's take another one. Something you'll see more in a combustion analysis. So this time the only difference is you were given a molecular formula mass. So that'll come into play in a moment. The same tricks work every time. First, assume 100 grams. Convert those masses into moles. Percents have went to grams because you assumed 100 grams. Now convert your grams into moles. And remember not to be skimpy on the sig fig. Okay? Set up your ratio. Divide by the smallest. In this case, that says that you're going to have 1 carbon, 3 hydrogens, and 1 oxygen. So you have an empirical formula of CH3O. But we want molecular formula. In this case, or to find any molecular formula, you take the molecular formula mass, which in this case was given, the empirical formula mass, which you can find from your empirical formula, divide the molecular formula mass by the empirical formula mass, and that should give you a number. It should be extremely close to a whole number. If not, I hate to tell you, but you're going to have to probably go back and start over from scratch. But once you have it, you multiply those subscripts out, and there you have your molecular formula. In our case, the empirical formula was CH3O, but the molecular formula was C2H6O2.